Okay, welcome to example 5, last example on 8.2 for Math 20-1. Just another kind of quadratic system. It's talking about somebody throwing a ball to a basketball player who's going to try to, dunk it as it approaches the net. And in order to do that, he has to be at the same location as the ball. But really the bottom line, and I like questions like this because, nobody's doing this equation as they play basketball, but little stuff like this is important, and intersection points are really the key concept when we talk about systems of equations. And I'm just going to kind of summarize down here what we're trying to do. We are trying to find the solution to this systems of equations that I'm writing below. Now, there is no, golden technique that is, exclusively better than others, but I think the fact that, the 5d squared minus 10d plus h is equal to 0 only has h or 1h means that that is a better choice for substitution. So I'm going to manipulate that formula and I am going to solve for h. And the way that I'm going to do that to keep h positive is I'm going to subtract 5d squared from both sides, and I'm going to add 10d to both sides. And what I get is that h is equal to negative 5d squared plus 10d. Now, with that formula, I can substitute it into the other equation. So d squared minus 2d plus 3 times what we just determined h to be is equal to 9. Now we have to expand this, so it's d squared minus 2d. Remember that that 3 has to distribute into the bracket, so we're going to have a minus 15d squared plus 30d. And at the same time here, I am going to move that 9 to the other side. And the intent behind that is that when we solve quadratics, we really do need to have one side equal to 0. All right, from here we collect our like terms. So we have negative 14d squared plus 28d minus 9 is equal to 0. Now that's so close, maybe kind of frustratingly close, to maybe be able to factor out a 14, for example. But the 9 really ruins that. So what we have to do at this point is you could try to factor it. This is not factorable, but you could try, two numbers that multiply to, whatever negative 14 times negative 9 is, and then add to 28. But I really do think that quadratic formula is a good fallback when you're doing the algebraic technique. So I'm going to say that the value of d is equal to negative 28, that's negative b, plus or minus the square root. And then inside that square root is going to be b squared, so that's 28 squared minus 4 times a, which is negative 14, times c, which is negative 9. And all of that, the whole thing, is divided by 2 times the a value, which is negative 14. Now, cheating a little bit in the notes for sure. When I clean that up, I get negative 28 plus or minus the square root of 280 divided by negative 28. And that's going to branch into the two solutions. And I'm going to write them here. We get d is equal to 1.597, a lot of decimals after. And we also get that d is equal to 0.402 with all those decimals after. Now, it is pretty important that those are just the distances that Ben is from the hoop, and the ball for that matter, I suppose. What we need to figure out is what height that it's at. Because we are talking about an alley-oop, it is not a good idea for Ben to try to, slam dunk it from 1.6 meters away. That's probably not going to end well, depending on how long his arms are, I guess. So immediately, I'm actually going to cancel this out. And the problem is that, when we talk about what's happening here, is that this is a valid answer, but I'm going to put that it's not useful for the alley-oop. I'll try to spell alley-oop right. Alley-oop. And the only reason for that is because it's further away from the net. So d equals 0.402 is close enough that unless with normal sized arms, he is going to be able to put that ball into the hoop. That being said, we still have to figure out what h is, but we have a formula for that. We said that h is equal to negative 5d squared plus 10d. So my h is going to be equal to negative 5 times 0.402 squared plus 10 times 0.402. And I end up with the height is equal to 3.214. Now, really what this is saying is that when Ben is 0.402 meters from the hoop, him and the ball are at a height of 3.214 meters. So I'm going to kind of write that underneath just to assume that when Ben is 0. And it says nearest 100, so I'll round at this point, 0.40 meters from the hoop, he is at a height of 3.21 meters. All right, now it says, what assumptions are you making? We're certainly assuming that, both of these objects are traveling normally. There's no, nobody else on the court, I suppose. And we're also assuming that, Ben's going to make the shot. Just a couple of kind of standard assumptions, nothing too crazy there. Those are typically not questions we ask. We're certainly much more focused on actually solving these algebraically. I am going to put up the standard assignment now for 8.2. We kind of told you just to make sure that you see some of them to do substitution and elimination for specific questions. We're not going to really enforce that on the homework assignment that we're modifying, but it is important that you are capable of doing both algebraic techniques. On an exam, we will specifically ask you to do substitution or elimination just to make sure that you do know that technique and you're getting, assessed on that technique. Okay, good luck and chip away at those homework assignments, please.